Stanford University.
All right. Welcome then to lecture number 8, I think it's 8, yes, of CS193P, spring of 2016. So today, I'm going to start off by continuing that demo that we were doing last time. Remember we had the demo, Cassini demo with the scroll view in there. And so I'm going to make it more powerful. We're going to get multiple MVCs going in there. We'll start doing some zooming in the scroll view. Depending on how the time goes, I might actually show you some things that a couple of you have asked about on Piazza, like when I launch my calculator app, can I have it not launch and show a blank graph, right? How can I have it launch and show the calculator for the very first time, okay? Those kind of things. So we'll see how the time goes and decide on the fly whether to do that stuff. Then we're going to dive back into the slides. I'm going to talk about multi-threading. Okay, very, very important thing in iOS is how to multi-thread your execution. And then I'll go back to the demo and we'll multi-thread this Cassini thing we're working on. Okay, and then time permitting at the end, I'll go back to the slides and I'm going to talk about text fields. And then next week we have table views, databases, etc. And again, remember, no assignment going out today. The assignment is going to be a table view based thing, so it'll go out after Monday's lecture. All right, so let's dive back into this Cassini demo. Okay, we'll start off just exactly where we left off before. So we'll go to Xcode here. So I'm just going to open Cassini. And here it is. I'm just going to run it real quick just to remind you where we were, for those with short memories, even though it was only 2 days ago. All right, here it is. So we've got our image view, right? We have an image view and it's inside a UI scroll view, and so we're able to scroll around, okay, just by panning with our finger. My mouse is like the finger there, so I'm just panning around. And that's all we can do, okay? But we've created this nice UI, or this nice image view controller, which is an MVC that lets you take any image and put it on screen inside the scroll view. That's kind of a nice reusable MVC. Right? So now we're going to make this a multi-MVC app, okay? And I'm going to reuse this image view controller as one of the MVCs. So let's go right to our storyboard, see what this is going to look like. This is where the Cassini part of this whole thing is going to come in. All right, I'm going to create a new view controller, just going to drag it out right here. Again, I'm going to go fairly quickly because I've done this all before, so this is almost like a review for you here. So I have this controller. It needs to have a custom subclass of UI view controller, so I'm going to create such a thing. Go here to New File. It's iOS source. It's a Cocoa Touch class because it's a subclass of an iOS class, which is UI view controller in this case. I'm going to call this Cassini view controller because it's going to let us look at some Cassini images. That's what our app is going to do. I put this in the same place as always. Here is our Cassini view controller. I'm going to remove the view controller lifecycle methods that it gives me right here, just for now anyway. And I'm actually going to uncomment this prepare for segue because my Cassini view controller is definitely going to be doing some segueing. So let's now go back to our storyboard now that we have this image view controller class. And I'm going to change the class of this controller right here with the identity inspector to be a Cassini view controller. Okay, everybody got that? I'm going to put this whole MVC structure into that split view with navigation controller in there, the thing that'll work on both iPad and iPhone, the exact same thing we did for the emotions view controller. So let's do that. I'm going to start by dragging out a split view controller. I'm going to zoom way out here. Let's go get a split view controller. Here it is. I'll drag it out. I'll get rid of these extra things that came along here with the split view controller because I already have my master and detail right here. The Cassini is going to be my master, and this image view controller is going to be my detail right there. So I'm just going to control drag, hook up my master. I'm going to control drag to hook up my detail. I'm also going to take my little entry arrow and make it so that it enters on the split view controller, right, instead of entering on my image view controller, obviously. And I want this to work on both iPhone and iPad, so I'm going to take my master and embed it inside of a navigation controller. Okay. And maybe I could even go in here and put a nice title here on here, Cassini. Okay. All right, now, what is this UI going to do? What's it going to look like? How's it going to function? Well, I'm just going to have 3 buttons here, similar to how I had in Motions View Controller. In a demo, I can't do a nice complicated MVC like a calculator and then another complicated one like a graph view. I have to do a simple one. So I'm going to do a simple one here, where I'm going to put 3 buttons, and those 3 buttons are just going to cause 3 different images from NASA, okay, about Cassini, which is a little thing sent out into space to take pictures. I'm going to put those 3 buttons here, and then we're just going to segue, as we know how to do, down to here, which is going to be our image view controller. Right? So the image view controller is just going to show the image, and we already know that the image view controller, it's a nice little reusable MVC that shows an image, so it's perfect, exactly what I want. So I'm going to go down here and get the buttons. So let's do this button right here. Let's go ahead and make it bigger. We'll say 40 point. It'd be a pretty good size here. And make 3 of them, copy, paste, so I get that. Okay, one of them is going to be called Earth, another one is going to be called Cassini, and another one is going to be called Saturn. Okay, and then I'm just going to take these 3 things, of course, and put them in a stack view. Okay, we'll go ahead and have the stack view be fill. And we'll also do, again, fill equally. It doesn't really matter because they're all identical. They're all buttons. And we'll put a little spacing in there, maybe 20 points, something like that. Then I'm going to drag this into the middle, use my blue lines right there so that I can go here and say reset to suggested constraints. And then I'm going to go over to my size inspector and double check that it did the kind of constraints I want, which that looks good to me. It's going to align these things in the center. Okay? So here's our UI right here. Now all we need to do is have these 3 things segue down to here to show these images. Now I'll show you where these images come from in a minute here, but let's just create this segue. Now I'm going to do something a little different with this segue. In our last one, each segue had its own identifier that was different, and it was the identifier that let us know which emotion to show in the emotions one. Here I'm going to have them all have the same identifier, and I'm going to use the title of the button to decide which image. Okay, so it's kind of a cross between what we did in the calculator and what we did in emotions, all right? So let's go ahead and create these things. So I'm going to control drag, okay, from Saturn down to here. This is in a split view, right? So I'm going to do show detail. That's the kind of segue I want, not show. Same thing with Cassini right here, show detail, and then up here to Earth, show detail. Whoops, not present modally, undo. Let's try that again. Show detail. Okay, so we've got these 3 things here. Let's go ahead and inspect them. I'm going to put an identifier on them, but they're all going to have the same identifier. And what that means is when prepare for segue gets called, it's going to be called, and the same thing is going to happen for each one. Again, I'm going to look at the sender and prepare for segue to know which button, but we're going to use the same code. So I'm going to call this show image because that's what it does. Okay, when you click on here to segue, it segues to this image view controller and shows an image. Okay, so let's make sure all 3 of them are doing that. Okay, so everybody cool with this? This is all just review. I haven't done anything new yet here. Okay, now of course we know if we want these little segues here to work, we need to prepare them. So let's go back to our Cassini view controller right here and do our prepare for segue. I'm going to show you something that's kind of nice to do from a clean coding mechanism, which is I like to create a private struct here to store my constants that are strings in the storyboard. So I usually call this thing storyboard. Okay? And then I just put these static lets inside. So the show image segue equals show image. So that this string, and basically any string that I put anywhere in my storyboard, like in these, when I inspect these things down here, like this string, okay, that's all collected here into this nice struct. Okay? So we already know that this is what we do to do constants. Okay, I'm just calling this group of constants storyboard. They're my storyboard constants, all right? All right, so let's do prepare for segue right here. What do we need to do in prepare for segue? Well, first of all, we probably want to make sure that this is the show image segue. So I'm going to say if the segue's identifier equals the storyboard show image segue, okay, then we know that this is what we're preparing for. And remember, in a complicated app, you might have multiple different kinds of segues, like we had in emotions actually, with different identifiers going off. So that's why we almost always check the identifier first, just to make sure that we are doing the right thing. And usually we'll try and spell identifier properly. Okay, so now we know this is the right segue. We need to get the MVC that we're segueing to so we can prepare it. So we know that's supposed to be an image view controller, so I'm going to say if I can let IVC, short for image view controller, equal the segues destination view controller as an image view controller. Okay? So if I don't even need parentheses there, sorry. So if I can get that destination view controller as an image view controller, then now I'm ready to prepare this thing. So how do I need to prepare it? Well, it depends on which button is doing this show image. Okay, so I'm actually going to look back at the button. Now, here's the button. Remember in Prepare for Segue, the sender is the button or the line in a table or something like that that caused it to happen. So I need to convert this into a button. So I could actually do this like this. I could say if I can let the sending button equal the sender as a UI button, then I can go forward here and say, let's let the image name, that's the name of the image we want to show, equal the sending button's current title. Oops, not current image, current title. All right, so this will be one way to do this, okay? But kind of a cool way here is this, right? So what if I took this, cut, and put it in here like that? Okay, so I don't need this. Except for this is if let. So if I put this in here, this is going to be an optional. I can't send current title to an optional. So how can I deal with that? Let's use optional chaining. Okay, so it's perfectly legal to use the optional chaining stuff on the end of some other expression that returns a possible optional. And remember, if this is nil right here, then this whole thing is just going to be ignored. That's what the question mark means. It means if it's nil, then just return nil and ignore it. That means image name is going to be returned to nil. Okay, see how I did that? Just cleans up our code a little bit to do that. Less if-thens and all that business around there. Okay, now I'm going to go get the image that goes with this button's title. Now let me show you how we're going to do that. This demo URL class, remember the one that had the little Stanford URL in there? Well, it also has these NASA URLs, one for Cassini, one for Earth, and one for Saturn. Those are the three buttons we have. And I have a little function right here that just gets the name of the image and looks it up in that dictionary right here, okay, and returns it. So this is a little function called NASA image named. So let's use this NASA image named. I'm just going to say right here that the IVC's image URL equals the NASA image named this image name. Okay, this thing I got right here. All right, and then, oops, sorry, this has got to be demo URL dot because it's over here in this demo URL. Notice this is a static function, right? NASA image name is a static function, so we send it to the class demo URL. That's why I had to put demo URL here. Okay? It's kind of a utility function for that little demo URL class. And while we're at it, you know what? Let's set the title of that MVC to be that image name as well. So that way we'll get Earth or Cassini or whatever as the title of that MVC. Okay, does this make sense? Everybody all clear? Now, let's go ahead and run this and see if this is working. There we go. Okay, there we go. So here's Cassini right here. And if I click Earth, okay, whoa, so it worked. I clicked Earth, but nothing's happening in my app. Oh, wait, no, it's showing Stanford. Why is it showing Stanford here? Well, that's because our nice reusable image view controller we have over here, its view did load smashes Stanford on top of everything. So that we only put that in there as a demo, right? So I'm taking that out. Sorry about that. Thanks. Everyone see what happened there? So now let's go back here. It won't be slamming a Stanford in there in our reusable image view controller. Okay, so now we go back to Cassini. We'll pick Earth this time. Again, it seems like it's kind of stuck. I can't click on any of these buttons. I can't do anything. Oh, there it is. Okay, so that must have been a really big image. It took a very long time to load, and here it is. It doesn't really look like Earth, but pictures of people on Earth. That's interesting. Let's try one of these other. Let's try Cassini here. Okay, what's happening? This is basically just blank. What's going on here? How about Saturn? Again, taking a really long time. You can see why we're going to talk about multi-threading a little later. Okay, and here it is. Okay, that's not good either. All right, so we got to start here. we know that Cassini's not working. It comes up blank. So why might Cassini not be working? Let's go back here and check, for example, to make sure that our segue is good. Okay, the Earth segue. Here's the Cassini segue. Let's go look at its identifier. Uh-oh, look at that. This Cassini identifier, no identifier. So let's put show image in here. Okay, so when you have a segue and it doesn't seem to be working, like it segues to the new MVC, but the prepare doesn't happen, often you want to go back and look at your identifier, make sure it's set properly or set in there. Okay, so now if we go back here, all right, we have Cassini here. Let's click on it. Again, it's loading. Oh, that one's must be a smaller image. It loaded pretty quick. And here it is. It looks like it's just a bunch of outer space. Okay, so we got a problem here, which is that these images that I loaded are huge. That's created two problems for us. One, our app gets blocked. See, I can't click on anything else. I can't even rotate or anything here. My app is just completely stuck. You never want your app in that circumstance. Never should your app be stuck like that. Users will just basically double click on the home button and kill your app and never run it again. They'll think your app is totally hosed. And it is if it behaves that way. Okay, so we really need to fix that. The other thing is this image is so huge that we can't really see it. So we'd like to be able to zoom in on it, right? So let's go ahead and do the zooming. Okay, how do we do the zooming in our back here in our image view controller, right? So our image view controller has this scroll view, right, that we dragged into the storyboard, and it's got this image view as the sub view of the scroll view. Okay, and we set our content size, so it's working nicely. And we know from the slides last time that to make zooming work, okay, we need to set some other things. Like, what are some of the things we need to do? Well, the most important thing is we need to set ourselves as the scroll view's delegate. Okay, so this is the first time you're seeing delegation demoed here. And the way we do that, I'd probably do it here in my scroll view did set here, right? The did set for my scroll view. Probably just say that Mr. Scroll View, please set your delegate to be self. In other words, send me any questions you have, okay, about how to operate. Now, when I put that in there, I have an error. Anyone guess what this error is? Okay, it's going to say that these types, this and this, do not match. Okay, and why is that? The type of this is, well, the type of this, not showing, but the type of this is UI Scroll View Delegate, which is a protocol. Okay, the type of this is UI or Image View Controller. That's its type. Those don't match. Okay, so that's why this says cannot assign value of type Image View Controller to UI Scroll View Delegate. Optional. Okay, so we need to say that this Image View Controller is a UI Scroll View Delegate. Okay, and we do that by just putting that right after our superclass there, little comma, UI Scroll View Delegate, and that says we are Scroll View Delegate, and all of a sudden this works. Now, UI Scroll View Delegate has no methods or vars in there that are not optional. In other words, they're all optional, so we successfully implement it, so the compiler is not complaining, okay, because none of them are required. But we still want to implement one, that zooming one, which is called View for Zooming in Scroll View. Now, one thing that's cool is once you say that you're a Scroll View Delegate, look what happens when I start typing View in Xcode. It knows I'm a Scroll View Delegate, so the very first thing it offers me is View for scrolling in Scroll View. View for zooming in Scroll View, right? So that's kind of cool. And what view, which of the Scroll View subviews do we want to zoom in on? Well, of course, the image view. Okay, there our image view right here that we store our image in. That's, of course, the thing we want to have its transform modified when we pinch in there. Okay, now you might think, okay, that's good. Got it all ready to go. Let's go start zooming. And we'll go over here. Let's get Cassini. It's kind of small. Okay, let's start zooming. Now, how do I zoom? It's with pinch. So I'm going to hold down the Option key right here and start pinching. And it's not working. It's not doing anything. Okay, I can still scroll, but I can't zoom in. Anyone know why? Is that louder? I think I might have heard it back there. Yeah, this right now, our scroll view by default, its maximum zoom and its minimum zoom is 1.0. So it is zooming to the maximum and minimum extent we allow, which is none, 1.0. So we need to set the maximum and minimum scrolling factor here, or zooming factor on this scroll view. So let's do that. Let's do that also right here when we're setting our scroll view from our storyboard. So we just say that the scroll view's minimum zoom scale. I'm going to have this minimum zoom scale, what did I think that worked well here? 0.03. So we're going to allow it to zoom way out, so make the image really small, okay? 3/100ths of its size, 3% of its size. And then the maximum, it is perfectly fine for us to say the maximum is 1.0. Maybe we never want the thing to be zoomed out any bigger than it already is, especially these are huge images already. So we can set the maximum zoom scale. We don't even need to put this because by default it's 1.0, but we'll put it in here just to kind of be very clear about what we're doing. All right, so now let's try it. All right, so let's go get Cassini right here. All right, here it is. Let's zoom in on it, right? I'm pinching. Oh yeah, look at that, it's zooming. Oh, and sure enough, look, there's Cassini. Making a little trip by Saturn. Okay, let's zip it around here so we can see a little better. Okay, how about some of these other images? Let's go look at the Earth. Didn't look much like Earth. Maybe if we zoom, we'll see something here. All right, so here it is, scrolling around. I'm going to pinch some more. Oh, look at that, it is Earth. Okay. Same thing with Saturn. Okay, everyone see what we did with the zooming? Zooming, quite simple in terms of the code you have to write, but you have to understand that delegation piece to really make it work. And let's see Saturn. Oh, there's Saturn. Okay, now let's try this on iPad. Okay, see what it looks like here. All right, so here is our master and our detail right here. So if I click on Cassini, hopefully Cassini will eventually, really slow, appear right here, okay? And we can zoom in here, okay? Now, what would be really cool here is if we could have a title up here that said this was Cassini, or Earth, or Saturn, right? So remember the kind of tricky way we did that is we went to our storyboard and we just put this one down here also in a scroll view. So we said embed in navigation control, or not in a scroll view, in a navigation controller. So I embedded in there so that now I have a title, right? And we know that if we can go and run this, it's not going to work, right? Because these segues are segueing now to a navigation controller. And so our prepare is not going to work because this line of code is going to fail, right? Because the destination view controller is now a navigation controller. And of course, a navigation controller is not an image view controller. Okay, it's the exact same problem we had before. So I'm going to show you now how to use that extensions mechanism to fix this. So I'm going to create an extension. This is exactly what I did in the slides, of UI view controller. Okay, and in this extension, make this scroll up a little bit so you can see it better. Okay, inside this extension, I'm going to add the var content view controller, which is a UI view controller. Okay, I'm adding this var to the class UI view controller. So all UI view controllers will now respond to this property content view controller. Okay, it's going to be get only. It's going to get it. And what I'm going to put in here is basically that same code I had in prepare for segue in a motion view controller. I'm going to say if I can let navcon equal self as a UI navigation controller. Okay, so in other words, if I'm a navigation controller, then return navcon.visibleViewController. Okay, the only problem with this is an optional view controller because the navigation controller might not have anything showing. Okay, so I need to return something because content view controller does not return an optional. So I'm going to use this defaulting to say if I have a navigation controller and it has no visible view controller, just return self, which is to say the navigation controller itself. Okay, otherwise we can just return self. So it's not a navigation controller, then the content is myself. Everyone understand that code right there? Okay, good. So now that we have this, we can just use that method right here. Okay? Instead of asking if the destination view controller is an image view controller, I'm going to ask if the destination controller's content view controller, and I can escape complete because now that's a method on UI. This is a UI view controller. This is a method on UI view controller. I'm just going to ask if the content view controller is an image view controller. Okay? So now we should be able to run an iPad and get some nice titles. All right, Cassini again. We've got the navigation controller up here. There's Cassini. Sure enough, there's the title, right? We set the title right here. IBZ title equals image name. Okay? And of course, we can zoom around. Okay? All right, any questions about that before I go back to the slides? All right, let's hit the slides here. Okay, so now we're going to talk about multi-threading so we can fix that problem where our Cassini app, when we click on the big images, just froze. Okay? When you build an app, never have it freeze like that, ever. In fact, if it freezes like that, probably you won't get through the App Store approval process. Okay? So the only way to stop it from freezing is to use multi-threading. Okay? So multi-threading just means we're going to have different threads of execution, okay? Different places in our iPhone or iPad where code is running, okay? And these appear to run simultaneously, but it'll even work on a single core processor, okay? Not a multiprocessor. It works then by time sharing, okay? So you got one thing running, another thing running, and it's kind of going back and forth, letting them each run a little bit. And maybe if one of them is more important than the other, it gets to run a lot, and the other one doesn't get to run so much, okay? But that's basically what multi-threading is all about. So how many people have done any multi-threading programming of any kind? Okay, so some of you have. Okay, about a little less than half of you. Okay, good. So in iOS, multi-threading is about queues. Okay, queue meaning, like if you go to the movies, maybe in England, they would say, oh, get in the queue, meaning the line to get into the movie, okay? So same thing here, and it's the same thing as queue in the computer science sense, right? A queue is a bunch of things lined up to do something, all right? And these queues contain in iOS functions, okay? Most of the time, these functions are closures, okay, that you've put in there, okay? Blocks of code that you put in this queue, okay? And then the system simply runs along in this queue, pulls the next thing off the queue, and starts it running in a separate thread, okay? And you can have multiple of these queues, and the system is pulling them off each one and running them in their own threads. Simple as that. You just got multi-threading, okay? Now, there's a little bit of trickiness here of what are these queues and how do you put things on the queues, but that's the fundamental way these work. Now, queues can either be serial, which means the function that's on the top of the queue gets pulled off, it runs to completion, and then the next one gets pulled off. That's serial queues. Or they can be concurrent, where the system pulls the top one off the queue, starts it running in a thread. If it's got more thread resources, it takes the next one off, starts it running in another thread while the first one's still running. And it might keep pulling a whole bunch of them off. Okay? So that's a concurrent queue. All right, so let's talk about the queues, how we get them, what we call them, etc. The most important queue, it's a serial queue called the main queue. Okay? The main queue is where all UI activity has to happen. This is super important for you to understand. That if you want to do anything where you call something in UI kit, okay, UI button, UI anything, all right, with a couple of exceptions, which I'll talk about later, you need to be making those calls on the main queue. In other words, you can't put those calls in a closure that you put on some other queue. Okay, it has to be on the main queue. All right? Now, conversely, all non-UI activity that's going to take any amount of time or resources probably wants to be off the main queue, so it never blocks the main queue. We want the main queue reserved for doing our UI stuff as much as possible. Okay? Now, this is not only because we want our main queue UI to be responsive, okay, that's the main reason, but also it serializes the activity on the main queue so that our UI is presented in an orderly fashion. If we allowed our UI to be on all these different queues, things would be drawing at all different rates and overlapping, and it would be unpredictable as to what happened on screen. Okay? So we use the main queue as kind of a synchronization point where everybody comes back to draw on the main queue. All right? Now, the main queue can only pull a closure or a function off of the main queue and work on it when it's quiet. In other words, it's not off doing something else, like drawing or something like that. Now, the system is using the main queue behind the scenes all the time. For example, you know about drawRect, right? I told you drawRect gets called by the system, and it doesn't get called, you don't call it, you don't tell it to, you just say set needs display. Well, you set needs display, and as soon as the main queue gets quiet, it goes and runs some function that causes that drawRect to be called. So you see how that works? Okay, so that's what's going on in the main queue. What about other queues? Okay, so in the next slide, I'm going to talk about 2 different kinds of other queues that you can use to run all your non-UI stuff. All right, so the first, I'm not going to talk about this now, that'll be on the next slide. So on this slide, I'm going to talk a little bit about how we put something on a queue. And the main way we do it is with this function right here called dispatch async. Dispatch async takes 2 arguments. One is the queue to put it on, like the main queue or one of these other queues. And the second argument is the function to put on the queue. Again, usually it's a closure. You see I'm using trailing closure syntax right there. Okay, this is 2 arguments. 1 argument, 2 arguments. So this is the closure you're going to put on there. What's cool about these closures, they take no arguments and they return no arguments. So they're really easy to put into your code. Okay, and you can put anything you want in here. Okay, but if this is going to do UI, you better not put it on anything but the main queue. All right, so how do you get the queue? How do you get this little queue argument? Well, for the main queue, you call this function dispatch underbar get underbar main underbar queue. Now you might ask, why is all these underbars and why does this look like this? This is basically a C API, okay, from iOS before Swift, and so it comes into Swift looking like a C API. These are just Swift global functions, but the reason this is not object-oriented, for example, is because this is a C API. This is called Grand Central Dispatch, actually. That's why they all start with dispatch, all this multi-threading stuff, and that's why it looks like this. I'm going to show you the object-oriented way to do this in a minute. But actually, we're going to end up using these C-like ones more often. All right? So again, all UI stuff have to be on this main queue. It's a serial queue. Okay, so nothing happens concurrently on this queue. Things happen in order, in the order they go in. Okay? And, but all time-consuming stuff, okay, or even worse, stuff that might block, like you're going out to the network to get an image, like we are doing, where that blocks, waiting for the web server on the other side to respond, all that wants to happen off the main queue. Now you still dispatch to that queue using dispatch async, okay? You go down here and you say, look at the bottom, it says dispatch async, not the main queue in here, and I'll talk about where you get that queue in a second. And then open curly brace, so this is a closure. Inside that closure, you do the non-UI thing that takes a long time or blocks. And then still inside this closure, you dispatch async again. This time back to the main queue to do the UI stuff that you need, maybe that the image you got from doing this, you now put this in the UI here. So look how I'm dispatching within a closure. So can you imagine this outer closure is off running on some other thread in some other queue, and in the middle of it, it puts a block of code, this block right here, this closure, it puts it back on the main queue. This one continues to run after that. In fact, dispatch async, that function always returns immediately. Because all it does is put things on queues. It doesn't actually execute any of the code inside the block. It just puts that block of code onto the queue. Okay? And then this outer closure just happily runs to completion and it's done. Meanwhile, that inner block has been posted on the main queue and it's just waiting for the main queue for it to be first in line and for the main queue to be quiet, and then it'll pick it up and run it. Got it? So this is why we use this C function notation, because it reads really cool. Okay, dispatch off the queue this, then dispatch the main queue this. Okay, it reads very clearly to the person who's reading your code what you intend. Okay, but you do have to remember that this is async. It's out of sync. Just because you say to execute this code, it's not going to happen right away. It's just being put on that queue. It'll happen sometime in the future when that queue is ready. Okay, when it rises to the top of that queue and the main queue is quiet. Okay? So how do we get these not the main queue queues, okay, that we want to run something else on? Well, there's really 2 ways to do it. The most common way is to use one of the concurrent queues provided by the system. Okay? Now, these queues provided by the system, there's 4 of them. Okay? They each have what's called a quality of service. And the quality of service is really how much attention the system gives to them. Okay? You can think of it as their priority. High priority queues get a high quality of service. They get serviced a lot. Okay? But it's not purely that, but it's generally that. Okay? So what are the 4 qualities of service here? One is user interactive. Okay, so you can get a queue. You can call this dispatch get global queue right here. And you can say, give me the user interactive queue. Again, it's a concurrent queue. So it's doing things concurrently. It's not serial. And user interactive means the user just asked to do something. It's going to take a little bit of time. So I don't want to do it on the main queue, but I need this done as soon as possible because the user is interacting with me right now. Okay? So this is very high priority, but lower priority than the main queue. Okay? So this might be something where the user is dragging with their finger and you're having to calculate something to make the image that's pretty intensive time-wise, and so you put it off in the thread, the user continues to drag, they're not seeing the result, and then the result comes back in, and then the user gets to see the result. So the result is a little bit behind their finger because it takes so much time, but at least as their finger tracks, the main queue is still listening to their finger, okay, and responding. Okay? So that's what user interactive is for. User initiated means the user just asked me to do this, but it's not in the middle of an interactive event, so you can take a little bit of time, but get back to me right away because the user just asked for this right now. Okay? So that's lower priority, obviously, than an interactive thing. Okay? Utility is something that usually runs in the background for a long time. Okay? Maybe it's fetching data, it's cleaning up some database somewhere. It's doing something that the user didn't ask to do, but that needs to be done for this program. So it's kind of that kind of thing. And then background is even lower priority. This is the kind of thing, well, it could run today or tomorrow, it's really not something I need done right away, I don't really care. So it's kind of just something that runs along in the background. It's only going to happen when things are really quiet, when nobody wants any other service. Okay? So you get one of these 4 queues by saying dispatch get global queue. You specify which one you want. Then this has this extra argument, (0), which is reserved for future use, so you just always put (0) there. And that's going to give you back a queue, a dispatch underbar QT, that you can then use as your first argument to dispatch async. Okay? So these are the queues you're most often going to put this work that needs to be done in the background onto. Now it's also possible if you create your own serial queue. Okay? You call dispatch queue create. You give it a name. This can be any name you want. Okay? This is usually just so you can see it in the debugger. Okay? This name is going to appear in the debugger. And then you say dispatch queue serial, saying you want a serial queue. Now you'll get a serial queue of your own. And it's going to be a pretty high priority queue, nothing like the main queue, but pretty high priority. Why would you ever want a serial queue? Let's say you had a big table that you wanted to download 1,000 images to put in that table, small little images, okay? Well, you could do it on one of these user-initiated queues or something like that, but it's going to fork off a whole bunch of threads and try to download as many of it can concurrently, open a whole bunch of network connections. Whereas if you do it serially, it'll do them one by one, okay? So it kind of throttles. It's a way of throttling your access to the network, right? You usually don't need this. These are usually what you're going to use for that not main queue. Okay? Now, we're only seeing the absolute tip of the iceberg on multithreading here. Okay? There's a lot more to GCD, Grand Central Dispatch. You can look in the documentation for all the functions that start with dispatch underbar, and you'll get an idea. There's at least a couple dozen in there. I don't have time to cover it in this class. You won't need it. You won't need anything more than I just showed you for the work that you're going to be doing in your assignments. In your final project, you probably also won't need any more than that, but at least you know where to look if you might need more. There is an object-oriented way of doing all this. There's 2 classes, NS operation queue, which is kind of like dispatch queues, and NS operation, which is kind of like those closures, right, those little functions. Why would you ever want this? These do have a little bit of extra functionality that they wrap from GCD. Things like, hey, I have these 2 operations, and this one depends on this one finishing. Okay? And so I'm going to put them in a concurrent queue, but don't let this other one go until the first one finishes. Right? So dependencies. You can have dependencies and things like that. We're not going to talk about that. You can look at the documentation if you want. You can do, I think, almost everything here with GCD. This would be more if you actually are building something where there's queues are doing queues and these operations are doing the actual calculation, like as your model is doing. You're doing some scientific app, and it's actually doing all this complex calculation where things depend on each other and all that stuff. And so it has a lot of queues and a lot of operations going. You wouldn't use it as much for things like I'm fetching something from the network and I need to put it in the UI, and I want that fetch to happen in another queue, right? That kind of stuff, you're just going to use the dispatch underbar. Okay? Now, in addition to dispatch underbar, you have to understand multithreading from the perspective of how iOS's API uses it. Because there are plenty of methods all throughout iOS that do what they do asynchronously using threads. Okay? And the way you see this in the API is that one of the arguments to these methods is a closure, right? It's going to be a closure you provide. And the documentation for that function will say your closure is executed off the main queue asynchronously. So what kind of methods are we talking about here that do that? Here's one that goes and fetches a URL, okay, from the internet, downloads it from the internet, and when it does it asynchronously. Obviously, you wouldn't want to block the main queue waiting for this URL to load. And when it comes back, it calls this closure right here. Okay? Now, inside this closure, you might want to do some UI things, like maybe you downloaded an image and you want to put it, but you can't put that code right inside here because this closure is executed on a different thread and on a different queue than the main queue. So what you would have to do in here is the same thing you have to do with the dispatch underbar async, which is you have to wrap dispatch underbar async get main queue around it. Okay? So here's the method. This is an iOS method, download task with request. It takes this last argument, which is a closure, and inside there you're going to have to do this dispatch to the main queue, because if you want to do something in the UI, because this is not happening, this closure will not be executed on the main queue. Got it? So we will talk a little bit about, you're just going to run into occasional iOS APIs that take these closures and they're asynchronous, and you just have to know that if you want to do anything in the UI, you're going to have to dispatch async back to the main queue. All right, so let's do a demo of this where let's fix Cassini. Okay, let's make Cassini so that its UI is always responsive even while it's off downloading these things. All right. So let's go over here. Okay, all this is going to be, all this code we're going to have to do is going to be in our image view controller. We're going to make our image view controller so that it is asynchronous, right? That it can load things asynchronously. Before I do that, actually, though, I want to talk one other thing we should be doing here, probably in image view controller. Notice that if someone sets our model, we immediately go off and fetch it. Okay? Now, what if we never appeared on screen? Okay? What if this were something that's going to be in a navigation controller, it got created, but no one ever clicked to cause it to happen on screen, but someone set our model? Then this wouldn't happen in Cassini, this app, but imagine an app where you've got this image MVC, and someone sets it. Really, we really wouldn't want to do this fetch because it could be very expensive, as we've seen, right? It goes on the network, it's pulling down this thing. If I'm paying for cellular data, it's costing me money, okay, to get that Cassini image. So I probably don't want to do this fetch image unless I'm on screen. If I'm on screen, I definitely want to do this. So here I'm going to say, so how can I tell if I'm on screen? If my view, okay, this is my MVC's view, the top level, if its window is not nil. Okay, that's a pretty reliable way to tell, that you are on screen, right? Because your view, your MVC's view, won't be in a window unless it's on screen. Make sense? We haven't talked about window much. That's that UI window class. I told you that you really never use it, and you don't. You're not going to send any messages to it here. But whether it's nil or not will tell you whether your view is on screen. Now, what happens, though, if someone sets my image URL, like in a prepare for segue, and then I do go on screen later? Now I have to fetch that image, okay, because now I am going to go on screen. So how can I find out in my view controller lifecycle that now I'm going to go on screen? Which method? Which method in my view controller lifecycle, remember? It's called, I'll put it down here next to this view did load one, view will appear. Okay, so view will appear is sent to you when you're about to appear on screen. Okay, and we always do super view will appear in all of these view controller lifecycles. All right, and here I'm going to say if my image is nil, then I better go fetch it. Okay, so this is one thing I've done to increase my performance a little bit. But it's still not going to stop things from blocking, because as soon as view will appear happens and I'm just about to go on screen, my whole app's going to freeze while I'm off fetching those big, huge images, right? So I haven't really fixed the problem. I need multi-threading for that. But I just wanted to show you to be a little bit careful about when you fire off an expensive operation. That's what view will appear is for. That's really where you want to fire off things like going out on the network and stuff. Okay? All right, so now let's do our multi-threading and fix this. And we're going to do this here in fetch image. We're going to make it so that fetch image does the actual fetching in another thread. All right, so how are we going to do this? It's pretty simple, actually. We're just going to take this code right here, which blocks the main queue while it goes out on the network to get the contents of this URL. And we're going to use the GCD to put it on a different thread. Okay? So I'm just going to say dispatch async. Okay? Remember, dispatch async takes two arguments, a queue and a block here, a closure or a function. Do that. So I'm going to put on one of those concurrent queues. And I'm going to put it on the one where the user initiated it, but it's not interactive. The user's not in the middle of dragging or something. They initiated it, so it's pretty high priority. And so I get that by saying dispatch, get the global queue. And the one I want is QoS underbar class user initiated, this one right here. Okay? This flags is always 0, right? And now I have this block here, so I'm going to double click on that. It's really nice, by the way, you can double click on these things to expand the block. I'm going to use the trailing closure syntax here, okay, for my block. This block, you notice it takes no arguments, returns no arguments. And I'm just going to put all this blocking junk inside here. Okay, so this is going to fix my problem, okay, except that it's probably going to make my app go all strange, because I'm going to be trying to do this inside a non-main queue, right? Because this queue, this block right here is going to be put on this queue, and so I can't do this inside of here. Question?
Can you explain the trailing block where you added the parentheses and what it does?
Yeah, okay. So this used to look like this. Okay, so this is normal. I'm calling this function right here, okay? Sorry, this function right here. Here's its first argument. See that? Here's its second argument, okay? If the last argument of any function is a closure, then you can put it outside of the parentheses. See this dispatch async parentheses starts here? So I just took this parentheses off of here, and I put it over here. Okay? So now this is the first argument to this function inside its parentheses. And here's the closure, which is outside the parentheses. Okay? You definitely want to get used to that, because we almost always are going to do it that way. And when people design APIs, they almost always put the closure at the end so people can do this. All right, so what am I going to do about this? Okay, I need this to be back on the main queue. Well, very simple here. I'm just going to dispatch it back to the main queue. Now, another thing I'm going to do here while I'm kind of at it is let's get this NS data right here. I'm going to assign that to a local variable here called contents of URL. Okay, and then I'm going to put, so that's going to be happening in my other queue. And then I'm going to dispatch async back to the main queue, which I get by dispatch underbar get main queue. Okay, same exact thing here. Okay, here's the block. I'm going to do the same thing, trailing closure notation. And now I'm going to put this inside here. Okay, but now the image data is this thing that I got right there. So that's contents of URL. Okay, now this is happening on the main queue. All is well. This image equals UI image. It's a UIKit thing. This is a UIKit thing, by the way, not actually because of the UI image. That is the one UI thing you can do on a different thread. But it's because when we say image equals down here, it's going to do something like image view.image equals new value. Okay, well, that's a UIKit right there. So that has to be on the main thread. So that's why I have to do that. Now, notice we still have an error here. Anyone know what this error is? It's pointing right here. What do you think it wants there? No idea? It wants self there. because this is a closure. Okay? This is inside a closure. And remember, whenever we have a closure and we use a property on our object, we need to put self in there to make it clear that we understand this is being captured and kept in the heap. So as long as this closure right here, which it's got this closure inside of it, as long as this is out there fetching, it's going to keep this view controller in the heap. Okay? Now, if we wanted to here, we could do the weak self thing here and have weak self question mark. And that way, if the image came back and our MVC had been thrown out of the heap, it would be fine. We would just ignore it. Okay, but I'm pressed for time, so I'm not going to do that. But you could hopefully imagine doing that. Okay, so everyone see what we've done here? So that's really all we need to do. One thing that it's a little, now I told you that multi-threading, it's pretty easy to read this code and understand what's going on, but you got to think of the bigger picture of what's happening with multi-threading here. For example, what happens in Cassini if I click on the Cassini, which is a kind of a small image, and then I change my mind and I click on Earth? Okay, so Cassini, which is small, comes back. Okay, this code is going to put Cassini on screen. But then the Earth is going to come back, and this code is going to put the Earth on top of it. Okay, so I'm going to get this flashing thing, Cassini Earth. Or worse, if I clicked Earth first and then clicked Cassini, it would show Cassini, and then later Earth would come in and it would be showing Earth, even though I clicked on Cassini. Okay, do you see the problem? Is that I'm firing off these network things in other threads. They're coming back at different times. So really, I want to, if I'm going to be a good programmer here, multi-threaded, I need to check and make sure that the URL that I'm fetching, that's this URL right here, is still equal to the image URL that I asked for. Okay? Then I'll do this. If it's not, then maybe I could print something like ignored data returned from URL, and then we'll put the URL in here. Okay? And I need self here, of course, because that's inside this closure as well. All right? Everybody got that? So let's go ahead and run, see if this works. So what we should have now is a very responsive UI, okay? All the time, no matter what we click on. So let's try it. Earth, Cassini. See, I'm able to click on different things. I can still rotate, okay? Whoops, wrong way around. And the it's going to pick whichever the last one that I asked for. It's still fetching right here. It's going to eventually, hopefully, get one. And maybe it's even easier to see this maybe. Let's stop this actually and go look at an iPhone, because you can really see it happening on iPhone, because when we click on them, it actually segues and comes back. So watch this. Are we running here? Oops. No, we want iPhone. Okay, so we go back here. Now I click Cassini. It's loading it, but I can go back. Okay, while this is still loading, I can go back and change my mind, because my UI is highly responsive, even though it's loading those things in the background. When they eventually arrive, it's going to put them in the UI, okay? But while they're out there fetching, I can do things like go back in my navigation controller. Make sense? See that?
Click out into the other view.
What happens?
Does that just start reloading the image each time you click out?
So the question, if I click out and then click back in, does it reload the image? And the answer is absolutely, because when I click out, it throws that MVC out of the heap. Okay, it's gone. Now actually, that MVC is not going to immediately leave the heap, because that closure that's doing the fetching is still holding it in the heap. But once that fetch comes back, then it'll leave the heap and the image with it. So yeah, every time we're refetching. Okay? Everybody got that? So see how we built this nice responsive UI right now? Okay? Even though it's still taking a long time to fetch things, we can still navigate. Now, what's a little weird about this UI though is that while it's fetching, like when I'm here, it's not clear what's going on. It looks like, oh, there's just no Earth image, I guess. I guess not. I don't see it. Wouldn't it be cool if we could give some feedback to the user? Hey, I'm working on it. Okay, this image is big. All right, and we can do that. And the cool way to do that is with a little spinner. Okay, a little animating. You see them all in apps, a thing that spins around. Basically telling them, yeah, I know, I'm working on it. So let's put a spinner in there. Turns out to be really easy to do spinners in iOS. We're just going to go to the storyboard. Okay, I'm going to put the spinner here in this view. Now, when I put it in there, I'm going to have to be very careful. And this is a good chance for me to show you more about the document outline. But watch this. So I'm going to go down here. The spinner is just a thing you can drag out. You see it right here? Now, watch what happens when I drag this out. Okay, and I try to use the blue lines to put it in the middle and drop it. It looks like, oh, okay, that worked. That's nice. I can even go here and inspect it up here. You see, I can make a nice larger one. Maybe I'll even make it blue instead of white. Let's have it hide itself when it stops animating. We can do all kinds of cool stuff here. But actually something terrible has happened, which is that when I dragged that thing out and dropped it in the middle there, it made it a subview of the scroll view. Okay? In the interface builder, when you drag a view out on top of another view, it makes it a subview of that. Now you can't really tell that here, but that's what this little guy over in the corner, the document outline, is really great at. If you look at the document outline, do you see how the activity indicator is indented from the scroll view? Okay? That means it's a subview of the scroll view. Now if you don't want that, okay, no problem. You can just drag it up above. Now it's not a subview of the scroll view. Now, of course, it's not in the right order right now because I want this thing to be in front of the scroll view. So I'm going to put the scroll view on top of it. So now they're siblings, and this one is in front because remember the subviews list, the top ones are in the back, and the other ones go towards the front. So now we have this thing in the front. Okay? Now, another thing is, what if I want to have constraints on this to keep this in the middle? Well, I have to be very careful here too because those dashed lines were referring to the scroll view. So if I try to do reset to suggested constraints here, I'm going to get constraints that constrain the activity indicator to the scroll view. I don't want that. I want the activity indicator to be in the middle of its super view. And watch this. You can do control drag in the document outline. So I'm going to control drag from my activity indicator to its super view in the document outline. Not over here, but in the document outline. And when I let go, I can do things like, oh, yeah, please center it vertically and horizontally in yourself. Okay? So now this thing is centered in the middle. Okay? So now we got this spinner. How do we do anything with it? Well, we need an outlet to it. So I'm going to bring up my code over here. Okay? Do automatic. Got our image view controller here. Let's get rid of this. Oh, let's get rid of that. Get some room. Okay? So I'm just going to create an outlet from this little spinner right here, over here. See it? Make sure that its type is UI activity indicator view, not something else. And I'm just going to call it spinner. I like spinner as my name. And it's just an outlet. It's a normal outlet, just like our scroll view or anything else is an outlet. Okay? Just like your display was in your calculator. There's nothing particularly special about it. So now that we have this nice spinner right here, we just need to turn it on and turn it off. So where are we going to turn it on? Well, I'm going to turn it on right before I start doing something on that other thread. Okay? So right here, when I dispatch onto this other thread to go do this NS data, which is going to block, I'm just going to say spinner start animating. And I'm going to be even trickier and go spinner question mark start animating, just in case I'm fetching my image like as a result of prepare for segue. Okay, because there my outlets aren't set. So even if my spinner's not set, I'll just do nothing. Now, where do I want to turn it off? There's actually two places you could turn this off. One good place might be down here when your image gets set. Okay, because if someone sets your image, then you don't need to be spinning anymore. By definition, you're showing the image, so it would make no sense to be spinning. So that's a good place. You gotta be a little careful though here, because what happens if you get in here, okay, and you get to the URL here, and the image data wasn't able to be found, so you never call set image, so it's never going to stop. So you probably want to put an else spinner stop animating here as well. Okay, so this is going to stop the spinner in the case where it went off onto the internet to get something and it couldn't find it. Okay? A little tricky. Okay, so let's see how that works. All right, here we go. Let's try Earth. There it is. It's spinning. We can go back. Let's try Cassini. It's spinning. Now, when Cassini appears, it stops spinning, and so it hides because we set this switch over here on this when we inspected it called hides when stopped, right? And so since it hides when stopped, it's not here anymore. Okay, zoom in here. Saturn spins. Okay, we can rotate. Big image, taking a long time. There it is. Okay, so see how we've turned this into an app that's really responsive and really nice, and it's being as fast as it can. It's getting those images as fast as it can, but from the user standpoint, it's very responsive, and you really want to build them that way. Okay, so now I'm going to show two things unrelated to this, okay, but that you've asked about in Piazza. One is, notice that when we run this, let's run again, watch what happens. When we run, we get an empty image view controller, which is really doesn't make any sense. What we'd really want it to come, when we first run and this is empty, we want it to come up showing this view controller. So this is like with your calculator, you don't want it to come up showing an empty graph, you want it to come up showing the calculator. Because the empty graph is useless, it just forces them to do that back thing right here for no good reason. Okay? So how do we do that? Okay, this is another case where we need to use delegation. In this case, it's the split views delegate. Okay, split view controller delegate. So what does this code look like? Well, I'm going to put this in Cassini view controller right here. The first thing I need to do is I need to make the Cassini view controller be its own split views delegate. In other words, it needs to be the delegate of the split view it's in. So I'm going to do this in view did load. Okay, sometimes view did load is not quite early enough to do things for split views. You might have to do it in awake from nib even. But this will work in view did load. And I'm just going to set my split view controllers. Remember, every MVC knows the split view controller it's in, or the navigation controller it's in, or the tab bar controller it's in. So split view controller says what it is. Might be nil, okay? But if it's not, I'm going to set its delegate to be myself. Of course, as soon as I do this, I'm going to get an error because I didn't say that I was a UI split view controller delegate. So I need to go up here and say that I'm a UI split view controller delegate. All right, so that satisfies that error. All is good. Now, which split view controller method am I going to implement? Okay, hold on to your chairs for this one. Okay, by the way, again, I'm a split view controller delegate, so I can just start typing split view, and you can see it shows me all of the split view controller delegate methods. And there's quite a few, okay, about a dozen of them. And the one I want is the one that controls the collapsing of the detail on top of the master, because I don't want it to collapse that detail on top of the master if the detail is empty. Okay, if it doesn't have an image in there, I don't want it to do that. So this thing that controls that, it's called collapse secondary view controller onto primary view controller. Okay, split view controller, collapse secondary view controller onto primary view controller. Now notice it returns a bool. This bool you return true if you took care of this. You return false if you want the system to do the collapse. Okay? So this is a way where the delegate can do this collapse if it wants or not, and it just lets the split view know whether it did it or not. So that's what the bool is, to let it know when it did it. So this is actually quite simple right here. We just want to get the image view controller, okay? Well, first of all, let's make sure that the primary view controller, content view controller, is ourself. Okay, now it should be, because we're setting ourselves as our own split view delegate, so we should be the primary view controllers, the masters, content. Okay, so we should be that, should not be a problem. But now I'm going to say, on top of that, if I can let IVC equal the secondary view controllers, that's the detail, its content view controller, as an image view controller. Okay, so if I have an image view controller as my detail, and where, everyone know about where, right? You did your reading assignments, you know about where. Where is an additional clause that you can add onto an if. Okay, so I'm going to say where the image view controller's image URL is nil. So if I have an image view controller as my detail and its image URL is nil, then it's empty. There's nothing in there. There's no Saturn or anything else. So in this case, I'm going to return true, which is me telling the system, oh yeah, I took care of that. Okay, I put that detail, I collapsed that detail on top of the master, don't worry about it. Now I didn't actually do anything. That's good, because that's what I want. I don't want that detail to be collapsed on top of the master if the thing is nil, right? So I just kind of lied to the system and told him I handled it when in fact I didn't. Okay? Otherwise, we're just going to let the system do whatever it does. Okay? Return false. We did not handle this, so you handle it. Okay? So let's see if that works. Okay, so here it is. Look at that. Came up, didn't show me a blank thing. So it worked. Now let's click on one of these. Boop. Okay, it worked. So it collapsed the secondary on top of the primary when I wanted it to, okay? But if it came up nil, then it didn't show it. Everyone understand that? I know it seems a lot of long words in here, like primary view controller, secondary view controller, but this is just master and detail. That's all this is. And we're just checking where the image viewer is nil. Just returning that we handled it when we didn't really handle it because we don't want it handled. Okay, one other thing I want to show you is reusing the detail in iPad. Look at iPad. And we have the master detail right here. Every time we click on this thing, it's creating a new MVC here. Okay, creating a brand new MVC. And there's really no reason for that. Okay, we could absolutely just reuse this MVC right here. Okay, we don't have to create a new one every time. So how would we do that? How would we reuse this? Well, if we're going to reuse this, we can't use segues because segues always create a new MVC. That's what segues do. They create a new MVC. So we can't use segues, okay, to do that in that case. So let's go back to our Cassini right here, our storyboard, and we're not going to use these segues over here. Okay, see these three segues? I'm going to get rid of them. Get rid of, oops, not that. Click here. Get rid of that one. I'm going to get rid of that one. I'm going to get rid of that one. Because I cannot segue from these buttons or it will constantly create a new one of these details. Instead, what I'm going to do is use target action. So I'm just going to bring up my code here, some space. All right, and I'm going to do a target action message from each of these that reuses the detail to show the image. So let's do that. Let's just go control drag here. I'm going to call this show image. That's a good name for this action right here. And I'm going to have UI button be the sender because I'm going to know which one to show because I'm going to look at the sender. Okay, so I got show image right here. So let's go ahead and put the code in here. So show image is looks a lot like prepare for segue. We can only do this if we're in a split view, right? We can only do the show image thing here, this trick, if we are in a split view. Sorry, let me, just so we can see what's going on here. All right. Okay, we can only do a split view, so I'm going to first check to see that. I'm going to say, if I can let the image view controller equal my split view controllers, if I have one, view controller, sub 1, we know that's the detail, right? And actually, I don't want to use sub 1 because if for some reason my split view controller doesn't have a detail, then view controllers only have one thing. So I'm actually going to use view controllers.last. Okay, because last returns nil if there's no such thing. Okay, and then I'm going to grab the content view controller as always, and I'm going to check to see if that's an image view controller. So in other words, if I can get my detail as an image view controller, then I'm basically going to do this right here, in here. But here I don't have to say sender as UI button because the sender is a UI button, so I can just say sender, and it's never going to be nil there. Okay, and do that. So see what's going on here? So no segueing. I'm not doing any segueing. So when I go over here, okay, and I pick something like Cassini or Earth, okay, let's say. It loads it up. Actually, we've got to do one other thing, sorry. Back here in our storyboard, let's wire up all these buttons to do that. Okay, we only wired up Earth to do this show image. So let's do that. Let's go to automatic. All right, so let's do this one here, and let's wire up this one here. Okay, so now all three buttons are sending that same show image. So now we can actually demonstrate this. So let's do Cassini. Here it is showing this. And once this appears, or even before it appeared, I can hit Earth, and it's just reusing this. No segues, so there's no way I'm creating a new MVC here. It's just reloading it. Okay, just by setting the image URL on the image there. Got it? Okay, now, what about back on iPhone though? Let's go back to iPhone. Is this going to work over here? No, it's not, because it only does that thing if it's in a split view. Remember I said if split view controller. So if I hit Earth, it's not working at all now because it's not segueing here. Okay? So really what I need to do back here in Cassini is I need to say if I'm in a split view controller, then do this. Otherwise, I basically want to segue. Okay? So now I'm going to show you how to segue from code. Okay? You've only learned how to segue by dragging in storyboard. Now I'm going to show you how to do it in code, which is you just say perform segue with identifier. And you give it the identifier. So we'll use the storyboard show image segue. And the sender can be whatever you want. I'm going to have the sender be this sender button right here, this button that's asking us to show image. So it's going to be one of those Earth things or whatever. Now, this perform segue with identifier requires that such a segue exist in the storyboard. Okay? And we got rid of all those segues. So that's not going to work. We need to have a storyboard with this identifier. And the way you do this is you actually segue from the view controller itself. Instead of segueing from one of the buttons, when you want to segue in code, you segue from the view controller itself, from this little icon right here, down to wherever you want to segue to. So we want to segue to this right here. Put these close to each other. Okay, so I'm just going to control drag from here to here. It can be show because we're never doing this in a split view controller. Split view controller, we're doing the other thing. So we do show. We've got this thing here now. This one segue. This segue hooks up the whole view controller to here. We still need to set its identifier to show image. Okay? And now, back here in this code, when we do perform segue with identifier, it's going to do that segue. And we're segueing from the view controller to the other one, not from the buttons anymore, from the view controller. So let's see if that works now on iPhone. All right, Cassini, sure enough, it's working. Okay, so it's doing that segue. It's back to doing the segue. So this is a new MVC. Go back. This is a new MVC. But it's only doing it on iPhone because if you look at our code over here in the show image, if it's in a split view controller, it just reuses the image view controller that's already in the detail. Okay? You got all that? All right, I think I have time to do the last bit of slides here, whoops, which is on text field. Go through it pretty quickly. All right, so UI text field, I haven't been able to show it to you right now because it requires delegation to work. Without delegation, text fields don't work. So UI text field is like UI label, but it's editable. Users can touch on it, and then a keyboard comes up, and they can start typing in it. Okay? UI text field is not really a very mainstream input mechanism on the iPhone because the keyboard is very small. Okay? So you only want to use UI text field when you absolutely positively can't get the text from the user in any other way. Like you can't offer them a choice from a list of the things. They have to actually type it in. Okay? So be careful. This is not a desktop app that you're building. It's a mobile app. All right? So text field is not a primary input source. Now, the keyboard appears whenever a text field becomes the first responder. And you can make a text field the first responder by sending it the message, become first responder. And then it will become the first responder. You can make it stop being the first responder, in which case the keyboard will go away, by saying resign first responder. Okay? So the keyboard appears and disappears purely if there's something on the screen that wants to be the first responder. Okay? Simple as that. Now, delegation is used here primarily with the return key. So if you bring up that little software keyboard, in the corner there's a button called return. And if you click return, the text field's delegate will be sent this message. Text field should return. It's called should return because it returns a bool about whether it should do target action when that return happens. Because a text field is like a button. If someone types in there and hits return, it'll do target action. Okay, you can control drag and it'll do target action just like a button. But this text field should return either has to return true or it has to not be implemented by the delegate for that to work. But one thing, so you usually do implement this because one thing you want to do in here is resign first responder. A lot of times when the user hits return, okay, you do the target action, but you want the keyboard to go away. So a lot of times you'll do that here in text field should return. So you just need to set yourself as the UI text fields delegate. You got to say that you implement UI text field delegate, and then you implement this method. And inside just say sender, which is the text field that's sending this to you, resign first responder. Okay, you can also find out when editing has ended in your text field, meaning that the user clicked on another text field usually, and you've resigned first responder. Okay, anytime you resign first responder, you'll get sent this, and you can ask the text field, okay, what text is in you? Okay, so that's another interesting one. And as I said, text field is a UI control. You can do target action, just control drag. The keyboard, you configure the keyboard actually by talking to the text field. There's no UI keyboard object that you talk to in iOS. Okay? When you want to configure your keyboard, you talk to the thing that's bringing the keyboard up. In this case, the text field. And there's all kinds of methods in here you can look at. This is the UI text input traits protocol. So that's where you want to look in the documentation. For this protocol, remember a protocol is just a bunch of methods and bars. That's all these are. And these will set what kind of keyboard it is. You know, are you entering a URL? Is it a password thing where you can't see the text? All that stuff is part of that protocol. So you want to look that up. One thing about the keyboard, it comes up over your UI, so it might even block the text field that you're editing in if you're not careful about how you lay your UI out. And we are going to talk later in the quarter about this NS Notification Center. It's a way to get notified when things happened, and when a keyboard comes up and blocks your UI, you will get notified. Okay, and when we talk about this, you'll understand what you can do. You could move your UI up, out from underneath it, or maybe it's in a scroll view, you could scroll up or something like that. But you do have to be careful about this. The keyboard just, boom, comes up right on top of your UI, and it can really block things, okay? So you'll need to eventually learn how to respond to this notification. There's lots of other text field properties that are interesting here. You know, you can actually put a little button on the side. You can decide when the user touches it, does it clear out what's in there? You can have a placeholder in there so that when there's nothing in the field, there's that kind of a light gray text, kind of telling the user what's supposed to be there, that kind of thing. Anytime I show you anything in this class, like UI text field or UI button or anything, of course I'm expecting you to go read the documentation, okay? Otherwise you're just not going to know how to use these things. I only have a minute or two in these classes, in the lectures, to kind of tell you these things exist. You need to be able to go use the documentation to figure them out, okay? And this is a classic example, figuring out how to use text field here. Okay, yeah, they have these left and right overlays that are kind of fun. You control the layout, all kinds of stuff. The keyboard has an interesting var in it, which is, the input traits protocol called input accessory view. You can actually put a little view on top of your keyboard. You've probably seen that in some apps, right? It has kind of like a little view that has custom stuff. You can put your own view just by setting this var. It's kind of fun. All right, so that's it. On Friday, we do have a section. It's on UI testing, which is literally being able to record the UI being interacted with and then writing code that tests to make sure it's doing what it's supposed to be doing. That's a really cool feature in Xcode. And then next week, we're going to talk about table view and core data. Okay, table view is a way of showing huge amounts of data, and core data is a database to store huge amounts of data in. Assignment 4, since it's a table view based assignment, will go out at the end of the next lecture, and it'll be due a week later. And there are no more reading assignments. I can tell some of you haven't done your reading assignment because you don't know some of the questions I'm asked. Go back and read that stuff, really. It's not that much stuff. You should really understand all these things like the where clause, or you're going to be writing weird code because people say, why didn't they just use where there? Why did they put another if? Okay, so you don't want to be that guy. Okay. All right, I'll see you guys next week.
For more, please visit us at stanford.edu.